All right, hello everyone. Welcome to ECS 179 Gameplay Programming's first discussion section. Today we're going to be talking about exercise 1, the command pattern example. This is your first exercise. The important things you need to know is that we're assigning it today on GitHub Classroom. It is due next Tuesday. They'll be followed by the peer review, which will be the Tuesday thereafter, and then we're hoping to get you the grades the Tuesday after that. So each one of these exercises has a 3-week time window. You have deadlines in the first 2 weeks. We have a deadline on the third week. We will start exercise 2 on the second week of exercise 1. So there'll be a rolling pipeline. All right. So a few things you need to do. We'll go to the browser here. I will send out this information in the Canvas announcement, but for right now, what you'll see is here is how to use GitHub Classroom. So what you will do here is you need a GitHub account. We had recently sent out basic information on how to start GitHub, to make GitHub account and to make a Unity account. Please do that, and maybe sign up for the student special accounts as well while you're at it. So GitHub Classroom. For each assignment, you'll get a link via email. The link is also on Discord. The link is also on Canvas. Right now, you can find it in the announcements section on Discord. You can find it in the syllabus on Canvas. Oops. The syllabus on Canvas exercises. The first one is right here. So you'll click on that and you'll be able to pick your email address out here. And that will identify you with your email address so you can get started on the assignment. It'll involve pulling, it'll create a repository for you that you will then pull to get a repository that you will then you'll clone on your own machine, change, and then we will grade the master branch that is pushed to GitHub for your particular repository. So that's how you check in your code. You simply push it to master and we will take a cut of your repository when we start grading. All right, so that's the basics for exercise 1 as far as the GitHub information goes. Let's take a look at the actual assignment itself. So you can go to the README for the class, the syllabus. One more. Okay, good. Now we can finally get the sidebar out of the way. Actually, can I just get rid of the sidebar like this? No, I can't. Whatever, this is fine. I'm getting nitpicky here. All right, so exercise 1, command pattern. You can find it right in the assignment and due date section for week 2. Now what you'll see here is a README. This is the this is the description of the assignment. The description is as follows. The goals behind this project are 1, to allow for meaningful gameplay programming inside a Unity project. So we're getting you started. 2, to provide a working experience with the command software design pattern. This project is filled with examples using Unity to construct basic game systems, including item collection, scorekeeping, player movement, simple non-player character behavior, parallax scrolling, character transportation, a camera that follows the player, animated sprites, user interface elements, and input commands using the game pattern. That should be a typo. It should be using the command pattern. All right. So we'll go through this stage by stage. There are 4 stages to this assignment. Here is the breakdown. As noted previously, your completion of this assignment is worth 70 of your 100 points for exercise 1. The remaining 30 points will be for your peer review. So I tend to add progressive grading systems to these assignments. So stage 1 is pretty darn easy, we're 10 points. Stage 2 is also fairly easy, we're 30 points. And the stages get harder as we go on and a little more meaningful. This particular assignment is meant to be more introductory, so with still providing some challenge. Let me know what you think about the difficulty level as you go on. The due dates will be next Tuesday. They'll be on Canvas. We're going to grade what's on Master Origin in your GitHub Classroom repository. All right, so stage 1, stage 2, stage 3, notice how these have to deal with the command pattern. We'll be going through the command pattern in depth during lecture today, so that will also be recorded. We'll talk about it a bit during this section, but not to the same level of detail that we'll talk about it later. Stage 2, heave ho. We're going to make different pirate worker commands. This is a pirate themed exercise. Stage 3, motivation will continue. So this is a more difficult, or I guess more comprehensive use of the command pattern. Stage 4 is you get to design your own pattern. You get to design your own command. We're looking for some interesting novel work from you here. All right, so that's the basics. I don't want to go too much into each one of these. I want to look at the code and then talk about the stages. So let's get to that. All right, my code editor works. Unity is here. All right, so I simply cloned the command pattern exercise repository and opened it in Unity. So are there any questions about how to open a project? All right, I don't see any. I'm assuming you all can open projects right now. Oh, I see people typing. One moment. I will wait for the typing. Okay, maybe not. So if you need help opening exercise, we can handle that later. I'm assuming you have all opened the captain exercise. What you may have is a screen that is simply a camera and nothing else. In that case, you haven't loaded the basic scene for the game. So how Unity works is you need a scene. By default, it'll have an empty scene for you if it's your first time opening a project, or if you make a new project, it'll give you a default scene. Now, when you make games yourself in Unity, the scenes are one of the major constructs that you use to make sets of game objects or sub-scenes. It's a basic building block of Unity. It's a very scene-based system. So we have one for you. So if you go down your assets folder, you'll see there are several subfolders: resources, scenes, scripts. We also have sound. Let me just open that for later. Here, there's a scenes folder. Right now, this is a fairly simple game project that you can build a lot of things from later, but this is the scene, gameplay. So you can double click this to open the gameplay scene, and what you'll see is something like this. Any problems? Are you all following along at this point? All right. So let's take a look here. So we have a main camera. It has a transform. It is a camera. It has an audio listener, so we know where the sound is coming. We know how to position the audio in the world. And we have a camera follow script. And the target is captain, and the speed is 0.75. Right, so you can tell there's some things going on here. Also, there's a canvas with text and an event system. That is for keeping the score. It's the score interface at the top. Now we have the captain. So I selected captain from the screen. I hit F to focus on captain, and you see there's some things going on here. So first, we have a sprite here. Very a pirate-esque sprite, and we have two green boxes. Now the green boxes are the first is the outline of the sprite itself, or the sprite renderer. We also have a rigid body 2D, which is the collision surface, the logical collider. The physics object, so it has physics properties. That's what the rigid body is. Provides the captain the ability to interact with gravity and to collide with other objects and not move through things that are solid in the physics system. We also have a box collider 2D, so we know when we have logical game collisions as opposed to physics collisions. We have a captain controller script, and we have an animator. So the captain controller script is one that we've written. We'll take a look at that. The animator allows the captain to be an animated sprite. Let's take a quick look at the captain. So I'm going to press play now. On the recording, you'll hear sound. Maybe you won't through Discord. As a reminder, my machine is slow. Yours should do this a lot more quickly. All right, so we have Captain here. We can move Captain. Captain, so we have basic left and right movement, arrow keys, WASD, left click or control, left control will make him slash a sword using the motivate command, which we'll talk about later. You'll notice there are other pirates in the world. We're scrolling along this pixel art based background with parallax. The bombs, when the captain collides with bombs, it launches the captain to another level. Now we're at the graveyard, here with Scurvybeard, the pirate, moving around. Now we're back here with Cutlass in the Mushroom Forest. So we've looped back to level 1. There are 3 distinct levels here. Now we're in the mountains. Notice that there at the top, there's a score that we haven't accumulated anything yet. We have accumulated no score. That's part of what we'll be doing in the assignment. You'll also notice that we can only move right. Your first activity will be to make the captain be able to move right as well as left. The captain can only move left. Oh my gosh. The captain can only move left at the moment. Your first stage of the exercise will be to make the captain have the capability to move right. All right. So there's the captain. So now notice that we have the Mushroom Forest, the mountains, and the graveyard. These are the 3 levels that we have. You know, these are parallax scrolling backgrounds. So let's take a look at graveyard. All of these are structured similarly. So what we have are these game objects. There's a game object for each one of the layers, the parallax layers. There's a game object for the logical place the ground is. And then there's a game object for Scurvybeard, who, much like the captain, has a sprite renderer. So you can actually see the sprites of Scurvybeard. There's an animator, which allows us to animate and to have different transitions from different states for Scurvybeard. We have a rigid body 2D, so Scurvybeard interacts with the physics of the world. Notice he's floating a bit above the ground. First thing that'll happen is he'll plump onto the ground, which you can see where the ground is by this line. So the top level of the ground object. Scurvybeard also has a box collider 2D, so we can do logical, game logic collisions. And we have a pirate controller, which we'll take a look at. So we also have the 2 transport bombs, one on the left side, one on the right side. So you see we have the basics of the levels. If you go inside these game objects, we have you can see the assets and where they're highlighted when you click on each one of these. Looks like these were double loaded for some reason. It should be fine. So notice in the mountains, transport bomb 1, transport bomb 2, peg leg, and the ground. Peg leg is also similar to Scurvybeard, same setup. And the Mushroom Forest, which has Cutlass, transport bomb 1, transport bomb 2. So those are our 3 areas. What if an object has a rigid body and no controller? There will be no game logic to it. So the controllers, I'm sorry, do you mean the animation controller, or do you mean our controller scripts? As in Cutlass. Oh, no collider. I'm sorry. I read controller when you said collider. If it has no collider, it won't interact with the physics system, so it'll fall right through the world. Or, I'm sorry. The rigid body will turn off physics. So no gravity will, it won't be subject to gravity or collisions with other physics objects. It'll just be a free-floating thing. The box collider we use for game logic detection. So as you'll see later, we'll have an interaction between the captain and the other pirates. And without the pirates having, or without, for instance, Cutlass having her box collider 2D, we would have no way of knowing when the captain's interaction with Cutlass actually occurs. All right, excellent. Okay, so we have our assets folder here. We have resources, scenes, and scripts. So we talked about scenes, which is where our gameplay scene is. We have our scripts folder, which holds all of the scripts we have for this version of the project. You should have all of these in your project right now. Little note for Unity on here. You see at the bottom, I have this scroll bar. You can make the icons larger. My favorite thing to do is drag it all the way to the left, and you actually get list mode. So you can read things a little better. So if you drag this slider all the way to the left, it'll put the project browser into list mode, which I prefer. All right. We also have a resources folder where we have our audio, background, character art, item art, and prefabs. So audio, we have a audio pack, a set of audio files for you to use. Fire, water, and wind. I guess it's fire, earth, and wind are the ones we are using for the background music. We have chops and clacks and bounces and bloops that you can also use. You can play them at the bottom here. We have our background art. So we have a desert, a graveyard, mountains, and a mushroom forest. Desert is one we haven't used, but I gave it to you anyway in case you want to play with it. So another set of parallax art assets. We have our characters. So here is where we keep information about the characters. So first we have the captain controller. So this is the animator for captain. So captain starts idle when he's not moving, can walk, can transition to running after walking for a while, getting up to a certain speed. There's the motivate command, which is when you hit left control or left mouse click when you swipe to the sword. We call that motivate. So you can see the transition graph here. I'm happy to go over this during office hours. You won't have to mess with this for the assignment. So for each one of the assignments, I add in some depth to it that you can explore that are past the actual graded structure of the assignment. This is one of those. And while we're looking at the captain, let's go ahead and focus on the captain. All right. So we have different animations for the captain. So there's idle animation, motivate, run, walk. If we look at idle here, you can see it's just a basic animator. We're going to bring up the animation here. So you can see the different frames of the sprite in the animation. So captain simply moves in this way. It's a very simple idle animation. Let's take a look at motivate. So you can see here more discreetly that the captain is in repose, ready as the attack, slices down, and then the motion animation for the slice disappears as the weapon goes to rest. And then when that's over, the motivate action will be over and we'll go back to either idle, running, or walking. You can see the running command. You can see the little motion bubble down here, a little motion graphic dissipates. You can see the walk cycle, the run cycle, etc. So we have the same thing for Cutlass. Exhausted, idle, working. Same thing for Pegleg and Scurvybeard. Notice that we have a set of sprite sheets here. Characters. You can see these sprite sheets have been sliced up into individual animation cells, which you can see down at the bottom right. This enemy 1 is mapped to Scurvybeard. There. see this a little better. See all Scurvybeard cells of animation down here at the bottom. Here you can see all the animations stacked together. Enemy 2. Enemy 3. Which we haven't used. Enemy 4. So all these are unused sprites, except for enemy 1 is Scurvybeard. Now it actually, yeah, okay, so Pirate 1 is the captain. So you can see all the captain's animations here, different individual frames of animation. Pirate 2, Cutlass, and Pirate 3, Pegleg. So notice we have some extra pirates. I didn't use all the assets bundled with this game. You can see them for yourself. Play with them if you want. Maybe add them to the game for your last exercise. So we have Motivate, Idle. So we have animations made from each one of these sprite sheets. So we've taken individual frames of animation from the sprite sheets and put them in time sequencing. We time sequenced several of those animations together to perform an animation or a change of sprite over time. Each one of these pirates has an animator. So going from idle to working to exhausted is the basic layout for the NPCs. Pegleg has a similar one, as does Scurvybeard. Somewhere. All right. Items. So here's Scurvybeard. It's somehow got in the items folder. I must have messed up my project in some way. All right. Either way, it functions. So now we have a set of sprites for you. So here we have an animated black pearl, blue gem, which is one you're going to use. We have the bombs. So each one of these are little animated sprites. You can see the different. The bomb is basically spinning, as items often do in game worlds to show you that they're an active thing to use. Mushrooms are associated with Cutlass. The blue gem is associated with Pegleg, and the skull is associated with Scurvybeard. In the final version of your game, these are the pickups that you'll be using. But notice we have all of these animations. So we have the skull idle, so that's making the skull rotate. Same with mushroom idle, same with blue gem idle. All of these are the basic assets and animations. We have them packaged together for you in prefabs. So you're made, part of the assignment is to make a bunch of these. In fact, the pirates are harvesting these for you as the captain. So here's the blue gem prefab. If I open this up, you'll see we're now in the prefab editor, as denoted here. We see we have blue gem at the top saying, hey, instead of a scene, we are in the blue gem prefab. And the blue gem is here. It has a sprite renderer, an animator, a rigid body, and a box collider. It also has some sounds. It's an audio source. So when they're generated, an audio clip will play. And you can see the same thing for mushroom, skull, and the transport bomb. All of these are Unity game objects that we want to reuse time and time again. So we make prefabs out of them, basically like class definitions. So we can make new instances of them. Instances of them during gameplay. All right. Resources. We went through all of these. Prefabs are important. We have the prefab editor, which you can do by the little left arrow right next to where the prefab's name. We have scripts. So here's where things start getting a little more interesting. This is the code that makes our project work. I'll spend a few minutes here going over this, then we'll look at the assignment description. So first one we want to look at is the first one we described, the camera object follower script. You can see it right here. I'll open this up and then switch to code editor. All right, let's get this out of the way. So we have the camera object follow script that is on the wrong editor. One moment, I will fix it. It's Captain Move command, object follow, there. All right, so this is the entire script. It fits in one window. What do we have here? Well, we have first systems collections generic in Unity engine. These are, being able to use collections and be able to use generics and hook to Unity. All right, so this is a basic script that we have. You'll have a lot of scripts like this in your projects. The thing that allows a script to be placed on a game object is that it is a mono behavior that hooks it into the component system of Unity and provides a framework or a lifecycle or a set of capabilities around your script to be used with Unity. For instance, you'll see there's no constructor, but we can make a start function. We also have fixed update, which hooks into the physics system time update. Great, so taking a look at this, we have a public game object target, we have a public float speed. Now when you have public fields or member variables in Unity as part of a mono behavior, they have some special properties. One of those is that they will show up in the editor. So I'm going to pop back to Unity. Well, we have the captain here. And when we go to the captain controller script, I'm sorry, we are at the main camera. The main camera has the camera object follow script, and the target is the captain, and the speed is 0.75. So we can change these in the editor, which will then, there's a meta file created for each one of your code files. So when they're loaded in Unity, it will initialize the classes, and they will get these, they will have the values that you put in, that you initialize in the field declarations. They will initially have those values, but then Unity will quickly override them by a file it keeps around a meta file for each one of the game objects or each one of the entities in your scene. So if we change this 0.75 to some other value, Unity will change it to the editor value for you when it loads your classes. So Unity does some managing around your variables. But public variables are viewable in the editor. So Unity uses the reflection capabilities of C#. Reflection is the ability for a class to look at itself and examine its own structure and properties. So Unity uses that reflection on top of the scripts, on top of the mono behaviors to look for public, things like public member variables, and creates editor entries for those. Inspector editor entries here. All right, so we have a private target position. So what we're doing here, in start, we're looking at, we're taking this target position, which is the position the camera is in the world, and we're matching, and we are sort of like pulling the position from it. So we're taking this transform position and setting this target position to that, so we know what we're looking at. So the target position is where the camera will be looking. It's more meaningful in fixed update. So here we want to make sure that we have a target, so the captain in this case. So what we're doing is we're making a new vector 3, which is a Unity structure that holds a 3-dimensional point or movement vector. So we're taking the transform.position, taking our transform.position. So this is where the camera currently is. But then we're also taking the target's position. So we have two vectors, camera position, target's position. So we know where we're coming from and where we're going to. And we do a linear interpolation from the camera to the target at a certain speed. My bad, back to the code editor. Yeah. Thank you. So you can see what I just described here. We have a from vector, a to vector, and we are doing a linear interpolation between the two. So the camera is slowly following but lagging behind the pirate. Okay, so that's some basic things. So just to show you a script, how the camera controller works. Now, to motivate the other bits of code that we're going to look at today, we're going to go back to the browser. We're going to go both legs. So, stage 1. Create a right movement iCaptain command and use it in the Captain Controller CS script. Right, based on right axis of movement, to be sure, move character left as a reference, and use the following properties of the sprite renderer. So basically, we're asking you to move to the right. You're seeing canvas now. Right now, we're looking at the assignment description, stage 1. So you want to create a, so you want to use the move character left and make a move character right script. And we want to make sure the sprite's facing in the correct direction. So make sure you can use this bit of code to flip its X orientation to match the direction it's moving. So taking a quick look at this. First, we're going to look at Unity. We're going to go to the Captain, and we're going to look at the Captain controller script. Notice that it's associated with the Captain. It's right here. Let's take a look at it. Captain controller. Notice that we have some iCaptain commands. This is part of the command pattern. So we want a fire 1, fire 2, which is mapped to left click and right click, or left control, left alt on your keyboard. It's also, if you have a controller, it's mapped to various controller buttons, depending on your controller. We have a serialized field called text. So we use that for the user interface. We have int mushrooms, int skulls, int gems. These are to know how many of each type of item the captain has collected when you finish the assignment to help us calculate the score, or to do any other game objects with, such as maybe spending those currencies. So first thing we do here is we add commands in the start function. So when the script is first started, we add in commands to fire 1, fire 2, right, left. And then we add in some default text. Now this is the command pattern. So what we're doing here is we're creating instances of various objects that we create. So first, the captain motivate command is the thing we're adding to fire 1, which is the swipe. Fire 2, right, left. Notice we have a move character left in the left command. We have in right command, we have do nothing. Fire 2, we have do nothing. So that's the current map. You'll be changing these. Update. So this is called once per frame. This is the game logic update. So when fire 1 is pressed, we execute the fire 1 command. When fire 2 is pressed, we execute fire 2. Right? So now notice that we are not calling individual commands here. We or particular commands. We're calling whatever thing that is a command that is bound to fire 1, fire 2, right, and left. This is how you do things like key mapping. This is how you do things like key mapping, so you can change the mapping of your keys you press to different game actions. We also load an animator and we set velocity. You won't be dealing with this. This is part of the infrastructure of the project. Happy to go over during office hours, but not right now. And notice we have an on collision 2D, so we know when we collide with mushrooms, skulls, and gems. And we increment their counters appropriately and destroy the game objects. It's left control is fire 1 on keyboard. All right, so that's part of it. So what for exercise 1, we want to change your move right command from do nothing to a move character right command, which you will have to create. you want to create it based off the move character left script. Fire 2 is not right control, I think it's left alt. All right, so here is move character left. Notice it's a scriptable object. So a scriptable object is something that can be used in a similar way to game objects. They are hooked less into lifecycle. We'll talk about those more discreetly. They're also used for keeping, they're less weighty things you can use in Unity that you can associate with game objects. They can also be made as assets inside the editor. They're an intermediate space between asset and script, but they also hook in less to the lifecycle. So they're kind of useful for things like these character commands. So we have moving left with a speed of 5. And when we execute that command, so when the left control is pressed, this execute is called. So what we're doing first is getting the rigid body of the game object that's attached to you, aka the captain. And if the rigid body is not null, so it exists, we add we change the velocity that the rigid body is moving at. So we change it to be a new vector 2, so a two-dimensional vector. We're moving at negative speed, so negative in our case is in the left direction. We're moving at negative speed, which is set at the script, so you can change the script, the speed of the pirate by modifying the speed value. And then we set the rigid body's velocity, we maintain its y velocity. Typically, none of these characters move up and down. The exception is this one was when Captain is moved around with a bomb, or you add a jump command for your Fire 2. And we are flipping. So by default, you can see in Unity, the sprite is facing right. That's not handy when you want to face left. So we flip the sprite when moving left. It's up to you to unflip the sprite when moving right. So basically your move character right is a copy of this moving in the other direction. All right, I know we got started a little late. It is 9 o'clock now. Feel free to leave if you need to. I'm going to continue on, finish this, and post the recording. Okay, so that is stage 1. You want to make a move character right, and you're going to want to hook it in to the right movement command. So this one's make a new script, copy and change, move right, and add it to the controller. So basically what I'm going to do, I've taken a couple screenshots as class went on who's actually in the audience. Okay, moving forward. Going back to the browser, heave-ho is number 2. So these iPirate commands, we want to have slow worker, normal worker, and fast worker do something. So the idea here is that each one of these pirates will periodically generate a mushroom for Cutlass, a blue gem for Pegleg, and a skull for Scurvybeard. But we want them to have different levels of motivation. So we want them to be able to work in 3 different ways: slow, normal, and fast. So each one of those ones these are parameterized slightly differently. Yes, you should make a new file for moving right. That way we have a move right command and move left command. It's a bit more granular than most games have moved their commands into, but it's also a breakdown that's handy if you want to make, say, AI characters. You can know when you move left versus when you move right. You can make those be 2 distinct things, 2 distinct commands to follow. All right. You're welcome. So slow worker pirate command, it works for 20 to 40 seconds, so you'll have to use random. You'll have to randomly generate a number between 20 and 40, and while it's in this duration, it should produce 1 item every 8 seconds. This is the default command for all pirates other than the captain, so they should start as slow workers. Normal workers, so they should work roughly half the duration and produce an item every 4 seconds. And then finally, fast work works a very short period of time, but produces an item every 2 seconds. So we have these three different types of work. So you should track time with float variables. Time.delta time is very handy for you. We'll go over that a little bit more, but basically this is the amount of time between updates. So you can track to see how much time has happened since our script has last been updated. So that way you can reduce, you can take time.delta time, you could have a timer with, let's say a 2-second timer. Every time delta.time comes around, you'll decrement your timer by time.delta time. When the timer hits 0, time is up, generate an object. All right. So these are pirate commands instead of captain commands. So notice here in the script that we've looked at so far, we have commands for the captain. Now, so this is the iCaptain command interface. Basically, it says, hey, you have to have an execute. So interfaces are a common point of decoupling used in software engineering. We're using that capability now. Our iPirate commands look very similar, except they take a game object pirate and a prefab. So basically, we're using these to generate objects. So your prefabs in this case will be either the skull, the gem, or the mushroom. Now, here is the no work pirate command. This is the basic command that you have for pirates that you should work from. I've given you some variables that could be handy for you as hints on how to solve the problem. If you want to make your own set of member variables to do your slow, normal, and fast worker pirate commands, go ahead. The only thing that we really need is your execute to return true or false. That helps. That lets the workers know that lets the pirate know when the workers are done. So this execute is called by the pirate controller. So notice here we have the active command of the pirate, so what they're actively doing. Starts out with no work. Each update we call active command.execute. So this execute is called once every frame. As long as the execute returns true, the pirate is currently in a working command. If it returns false, the pirate is no longer working, and so we set the animation to exhausted for the pirate. So we know the work is done. All right, so when you complete stage 2, and you have your no work pirate command all filled out, you do your random number generation in here, you make instances of the product prefab, you return false after the work is done, you return true if the work is ongoing. So this is a bit of code for you to manage here, like 10 lines of code or so. When that is done, this will always execute false after the work is done, and then your pirate will go into exhausted. So by default, after you complete stage 2, there's code editor, browser, there we are. By default, your pirate should do the slow worker pirate command. So all of them should do that at the beginning. They should work 20 to 40 seconds, generate one item every 8 seconds, and then it should start returning false. So this should be idling. So they'll be spinning circles over their head. There we are. Got my mouse back. And that should be what you see. They should work for 20 to 40 seconds, produce an item every 8 seconds, and then idle. That's a successful stage 2. Now stage 3, motivation will continue until morale improves. So now we want to look at the motivate function inside the pirate controller.cs. So when the motivate function is called, it should pseudo-randomly, so you can just roll a 3-sided die and pick, roll a d3 and choose either slow, normal, or fast work. So that's how the pirate controller gets new commands. So motivate, right now it's just a function. We'll talk about how that function is called in a moment. So basically you want to take your 3 commands that you worked here, choose one of them inside of the motivate function in the pirate controller, and assign it to the action that the pirate has. pirate controller, the active command. So you want to set the active command to be a new one of those instances. So here's how you would make one of them. So here's how you make the slow worker command. So we're instantiating a new instance of the scriptable object called slow worker pirate command, and we would assign that to the active command. So taking a look at that, it's down here. So here's our motivate function. So motivate has been called. It's called externally. This .active command gets object.instantiate scriptable object create instance no work pirate command. So when you make your slow work pirate command, your fast work pirate command, or your normal work pirate command, you'll use those here. This should be, you should randomly generate a number. There should be some case or if statement that triages your choice, that randomly picks between those three, and then they should start performing it. All right. Now, looking at this, I want to complete the loop here. Let's go to the pirate controller. So notice that fire1 is captain motivate command. So why does that happen? So when fire1 is swiped here, the captain motivate command has some special logic to it. So opening up that script, so when you press left control, left mouse, or your fire1 command on your controller, this captain motivate command will be initialized, will be started. So basically it's a little animation here. So while it's active, so you can get an idea of how timers work here. So this is some code for you to show like a lap time bit of timer. Basically what the thing you want to notice here is that there is a collider 2D. So what we're doing is we're seeing the motivation box, which is a particular object in the captain. So we have the captain, which has its own collision surface, but inside of that is the motivator. That's this green line here. The motivator is simply a box collider 2D with a position. That is basically the collision surface that is active when he's doing the chop, when he's doing the attack animation. So while that attack animation is active, we're seeing what it's colliding with. And when it collides with something, active is false, so it's been successful. We don't want to do multiple collisions with one attack, so we simply do it once. We see the contacted object, which in this case, given how this project is set up, will be a pirate. We want to get the pirate controller from it, so we're actually getting a reference to a component of the thing we've hit. So notice that we are making sure that the thing we hit is tagged as a pirate using Unity's tagging system. So we know this is a pirate, so it has a pirate controller. And what we're doing is we are calling the motivate function on the pirate controller. We're directly calling pirate controller. Come on, load. There we are. We're actively calling the motivate command that we just looked at in the pirate controller. It's being called for us inside of the motivate command. So this is how we chain in an action that the player does, okay, motivate with the pirate, to starting a worker command. So we want you to complete that here. That's stage 3. Now stage 4, make something of your own. You can be like doing something simple like jump is okay. You'll get your points for it, but a lot of you have more skill than this. A lot of you have more design intent. A lot of you have more experience. Do something fun. We've had everything from a currency system to augment the pirate's weapons or to have a cannon barrage, all the way to the pirate being like on Control 2 singing a sea shanty that someone's singing group had sung and recorded and added as an asset to the game. There's all sorts of things you can do here. I see we have a question. Do you have to make a new file for Move Right? Yes, you do. Oh, I'm sorry. That was the same question as before. My bad. It still is marked as new in my folder. All right, so stage 4, you want to make a new command, bind it to fire2, make it interesting. The lowest bar of success is making the captain jump. A high bar can be very high. interesting high things can be worth, participation points, will definitely enhance your grade, that sort of thing. So we're looking for you to exercise your own acumen here. And we'll pick the ones we find to be the most compelling, and we'll show them off during class. Give you some props. Okay. So that was a brief overview of exercise 1. I'm sure you have a lot of questions. There's a lot of detail here. There's a lot of things going on in this Unity project. Please explore. Please ask questions on Discord. I will hold office hours. You can ask questions then. We can ask questions during class today. I'm happy to help you fill in the blanks here. We will also partner this with a discussion of the command pattern in more detail during class today at our 1:40 lecture meeting time. All right. I know we're already past the end of class. Thank you, those who are staying. Do you have any questions before we stop the recording and end the session? For stage 2, I understand produce the item, but what does the 10 and 20 seconds mean? All right, so basically that is the range of which the workers are active. They will be producing one item every 4 seconds in the normal worker command during that 10 to 20 second duration. So when that normal work command is generated for the first time, okay, motivate hits, it randomly selects normal work command, and that starts being active. When it's initialized, when that command is first generated, you want to pick a value between 10 and 20 to represent the number of seconds that the pirate should be working for. And while that pirate's working, let's say it's 12 seconds, it'll generate an item every 4. So it would generate 3 items for that particular instance of normal work command. If it goes all the way to 20 seconds, you'll generate 5 items during that work. So partials don't count, right? The pirate will just give up and stop working when it gets tired. And let's say if it ends up being a duration of 13, it will generate 3 items. 1 second will be wasted. Will we need our laptops in class, or would it be okay to just watch? I'm leaving your technology policy up to you. If you don't want your laptop in class, feel free not to use it. Whatever you think is best for your classroom understanding. If you want to focus and pay attention and watch and take notes with no laptop, excellent. If you want to follow along with your laptop in front of you for that type of learner that likes to be hands-on while we're doing things, feel free to do that as well. All right, any other questions? I know this is a lot. The code that you're making is quite simple. There are not many lines of code, but you understanding how your code fits into the larger project structure is sort of the goal for this. You have a week to do it. We'll have TA office hours. We'll have my office hours. We'll have a lot of support for you along the way. Feel free to collaborate with your friends and other folks. You're responsible for your own learning. If you do work with someone else, please let us know so we know not to, flag any academic dishonesty or anything. A lot of people have fun with this assignment. I hope you have fun with it as well. There's a lot of fun things going on here. Okay, another question. So after slow worker pirate command is done, the pirate will just stop doing nothing. That is true. So what'll happen is your pirate controller will continue to call execute, but it'll be calling execute on a function whose time has elapsed, on a slow worker that's already done its work. It'll be past its 20 to 40 second duration. So it'll continuously return false when execute is called. That false command is sent directly to, I'll show this in the code editor. It's in the pirate controller. So here, this working command, active command, will be executed. It will return false, so working will be false. So that means we're sending that exhausted state to the animator, which will then have the pirate sit there and be dazed with a dazed circle over their head. So it will not be working. It will look like it's not working. When it is working, so when working is sent as true, so when your active command is actively working, when true is sent to it, it will be not exhausted, which means it will be doing its attack animation to harvest gems, mushrooms, or skulls. Does that make sense, Wei? Excellent. All right. How does Unity connect the animation of an object with its command? Like for stage 4, if I want my captain to jump, we cannot set its velocity to Y value, but also need to assign a proper animation, right? Yes. So we can talk about this during office hours, but the brief thing here is going to Unity. We have, for example, in resources, characters, we have the captain controller. So this captain controller is an animation controller. And you can see here, let's make this just a little bigger, that there's a set of animation states that the captain can be in. Whoops. So we have walking, running, idle, motivate. So each one of these are handling what the captain's doing, right? So when the captain is walking, so we have these transition states. The captain's idle. When the captain is walking, meaning that the speed is moving up 1. The captain will be in its walk command. So we'll go from captain. So captain walk command will be ran. This will be the animation ran captain walk. You can see it here. So captain walk is directly is bound to this animation here. So the captain walk state is bound to the captain walk animation, and it'll be running at the speed of 1. Captain run, we transition to that and call captain run. Where are the... Anyway, so we transition from walk to run to motivate. These are set on speed conditions on the captain itself. I will get into, I can show you, give you a little tutorial on how this system works. I know we're running way late on time. I can give you a tutorial of this during office hours. But this is the basic way that these happen. So each one of these states are bound to game state, such as the speed of the captain, or whether the motivate captain is actively doing a motivate command. And we transition to these with various data structure values, speed or booleans, floats being speed or booleans being motivate, transition between walk, run, idle, etc. So you can add a jump in here. So when you do the jump state, it can be match motivate. So when jumping is true, you can do a jumping command. And so you'll have to make a new animation with the captain sprite that makes it look like he's jumping, and add in a new state in here. So you have to engage with the system. You have to make an animation, you have to add it to the controller, and you have to add a command for it. So that's the basic 3 parts of what you'll need to do. And you have to handle the physics as well during the command. So giving it a Y velocity, etc. All right, any other questions? All right, well, I'm going to stop the recording. Feel free to ask questions in Discord, and I will see you all this afternoon. All right, take care, everyone.